Okay, this video is for the rest of the questions in section B for the 2019 media paper. So during the lesson in class, I wrongly mentioned that this working was for part C. So no, it is for part B. Okay, so now moving on to part C. They tell us that the volume of the cuboid of a cuboid is 2160. So 2160, we've seen the number appear in the question in part A and B. Now they tell us that to find the dimensions of the cuboid, so we are talking about the length, the breadth, and the height. They further tell us that all the heights are longer than 10 cm. Okay, so let's take a look at the prime factors of 2160. We have 2 power 4, 3 power 3, and 5. Okay, so let me write this clearly. 3 power 3. We are trying to find 3 numbers when multiplied together to give us the length, the breadth, and the height, all of which are greater than 10 cm. So 3 numbers multiplied to each other to give us 2160, and each number is greater than 10. So what options do we have? If you break down our prime factors, we have a combination of 2 times 2 times, okay, let's use brackets, save some space, 2, 2, 2, 2. We've got 3 of 3s, and we've got a 5. So knowing that these are the options that we have, we are free to rearrange them such that every single length is greater than 10. Let's start with some trial and error. Suppose we use 2 times 2. So that gives us only 4, which is not greater than 10. Let's go with another 2. That only gives us 8. Let's go with another 2, and now we get 16. Okay, that settles one of it. Let's go on to the next breadth. Let's go with 3, 3, and 3. So 3 times 3 is just 9, and now with another 3, we've got 27, and leaving us with only 5. And that doesn't help us with the length because the value 5 is not greater than 10. So we need to rearrange, we need to make some changes to it. Now I cannot just remove a 2 over here because that leaves me with the length of only 8. I can't just put a 2 over here because now my length is less than 10. So we have to do more try and error. So what if I remove another 2? So that gives me 4. And what if I put a 3 over here? Okay, so that removes one of the 3, and I know that I've got another 2 2s available. Okay, so now I've got length of 12. My breadth is only 9, my height is 10. It has to be greater than 10. We have to keep on trying different combinations. And we also now have a clue that we want every single length, breadth, and height to be slightly more than 10, so they will fit. And now this 12 that we found out is quite close to 10. So maybe we can use another 2 times 2, since there were 4 2s, and we multiply by another 3. So now we have used up 1, 2, 3, 4 of them. We've used up 2 of the 3s, leaving us with 3 times 5. So this trial and error process can be shortened, okay, can be made faster with some mental work. Okay, so now we have the 3 different dimensions already, and they are 12 cm, 12 cm, and 15 cm. Okay, now next one, the sum of money is divided. Find the smallest share will receive $8 more if the sum was shared equally instead, and find the total sum of the money. So many different ways of doing it. I would choose to let X be sum of money. Okay, so right now the smallest share, current smallest share is 2 units out of 5 10 units times X, which is 1 over 5X. This is the current smallest share. Now, what happens if I were to share the original sum of money equally into 3 equal parts? So after equal sharing, each receives x over 3. So they also told us that the smallest share would receive $8 more if it is shared equally. So the difference between these two values will be 8. Okay, so if we take the larger fraction, which is x minus 3, we take away x over 5, we get 8. This is the formation of the equation. So now we've got 1/3 x minus away our 1/5 x, make sure the denominators are the same. So we get 5x over 15 minus 3x over 15. This gives us 8. So 2x over 15 equals to 8. I'll just carry on over here. 2x is now equivalent to 120. So x be 60. So the total sum is $60. There are other ways of doing it. For example, you can use ratio. So next one, 14. Quite poorly done. Find the value of d. Just straightforward. Copy and make the changes. Every time you see unknown, put brackets. Put brackets. Be very clear about where the power is. In this case, power 2 belongs to the entire value of b. And typically, the setter will want to put b with a negative value because they want to check whether you are going to make a distinction between -3 square versus -3 entire thing square. Because the first one will give you -9 versus +9. And clearly, this is the correct one. And that's what I want to test you. So by following my instructions, that is every time you see a letter, you replace it with a bracket, then you fill in a blank, you will avoid this trap. Okay, so let's start with B. B has a value of -3. For A has a value of 2 and C has a value of 1. So putting them all into the equation, into the formula, we have square root of +9 minus 8, which gives us square root of 1, which is just 1. So the value of D is 1. Notice that given in the question, it is a positive square root. They did not put plus minus. So we are expecting a positive value of 1. You compare that with part B, part 2, where they ask you to make B the subject. Let's copy down the equation first. So D positive square root B square minus 4AC. I want to make B the subject. So it is like peeling an onion. You have to start with the outer layer. And finally, we get to the inner layer, which is the innermost layer, which is B. That is what we want. So let's peel out the outer layer first. The outer layer is a square root. To reverse a square root, we need to square. So square both sides, we get B square minus 4AC. We have peeled off the first layer. Now we're going to peel off the second layer. The second layer says -4AC. So to get rid of the -4AC, we need to add -4AC to both sides. D square plus 4AC. This gives me positive B square. Now we have one last layer to remove. That last layer is the square that belongs to the B. Now you are going to remove the square by introducing a square root symbol, because the reverse of a square is a square root. When you are the one introducing the square root, you have to include the plus minus sign. So D square plus 4AC. And this will be equal to B. Since they want B to be the subject, we put B on the left hand side plus minus D square plus 4AC. This is our solution. Next, simplify. Follow the instructions, you'll be fine. We see a fraction. We have 3x squared times y, and we square the whole thing. So what does that mean? We are simply multiplying 3x squared y by itself. So I'm going to remove the square and I'm going to change it to become 3x squared y. So look at the numerator. What does this mean? It's 3 times x times x times y times 3 times x times x times y. Okay, so we can deal with that a little later. Now in the denominator, we have 12 times of x multiplied by yz square times itself, yz square times yz square again. So this is what it means if you were to expand everything out. Okay, so let's get back to the numerator. 3 times 3, let's deal with the numerator, the numbers first. 3 times 3 gives us 9. Okay, we have settled that already. Now we have x squared multiplied by x squared. X squared multiplied by x squared just refers to this, x times x times x times x. So we get x power 4. So this gives me 9x power 4, and y times y, definitely you know it is y squared. Let's move on to the denominator. Denominator, same thing, we start with the number. The number is 12. Nothing to change over there. Next, we have x, only one x. So put it down. We have y times y times y. So we have y cubed. Then we have z squared times z squared times z squared. So what that means is that we have z square, which is z times z, that's our z square, times another z square, times another z square. So total we have z to the power of 6. Z to the power of 6. Now is the time for us to cancel. We cancel only common factors. So we can divide the numbers by 3, leaving us with 3 and 4. We have 4 x's in the numerator. When I say 4 x's, I mean x times x times x times x. And we have 1 in the denominator. We can cancel away one of it. So instead of power 4, we become power 3. There is y times y in the numerator, and there are 3 of them in the denominator. So when you cancel 2 of them, you are left with just 1 in the denominator. So this portion, the cancelling has to be done in pencil in case there are changes to be made. You make any careless mistakes. Okay, so the number first, we've got 3. We've got x to the power of 3 left. No more y term. Over 4. No more x. We only have 1 y. And we have 6 z. So this is our final answer. Next, we have simultaneous equations. This is quite troublesome because it is not we see fractions, okay, instead of integers, so it gets a little troublesome. But the standard 2 approaches will still work, either your substitution or your elimination. Now today I'm going to, because I see the coefficient of y is -1, there is a 1, so I think it is quite easy to change it to make y the subject. So I will choose to use substitution. Definitely, you can choose to take equation 1 multiplied by 2 so that you obtain -2y. Then you eliminate your -2y, which is found in equation 1 and equation number 2. You can go and try that yourself. But now I will do our substitution. So from equation number 1, these are standard presentation. We make y the subject. Mentally, if you can make y the subject, go ahead. If you cannot, do it step by step. So we get 2x minus 43 over 12. I will call this equation number 3, immediately sub into equation number 2. And let's see what we get. 3x, no change, minus 2 times of y. Every time you see the y, replace it. Minus 43 over 12, and this gives us -19 over 2. Now we will just solve for x. So 3x minus 4x, okay, do the expansion, minus 4x plus 43 over 6. This gives us -19 over 2. So on the left hand side, we've got, put on the equal sign, 3x minus 4x is -x. I'm going to subtract 43 over 6 on both sides. So negative, since the denominators have to be the same. Or if you're using a calculator, you don't have to bother about that. Let's subtract 43 over 6 on both sides. we get 50 over 3. So our x value is simply 50 over 3. Immediately sub into equation number 3 back here. So we get a y value of 2 times of 50 over 3 minus 43 over 12, which gives me 119 over 4. So x 50 over 3, y 119 over 4. Next one, 15a. 20 balloons in a bucket. X are red, remaining are blue. Cost of each red is 70 cents, each blue is 55. Find the largest number of red balloons that have been placed such that total cost does not exceed $13. So this portion, total cost does not exceed $13, tells us we should be using inequality. Get your inequality sign, greater than, less than, greater than or equal to, less than or equal to. So let's get started. Total is less than, if they say does not exceed, then it can be 13. So then what is the total cost? Total cost is made of X red balloons, each of the red cost 70 cents, plus the number of blue balloons, which is given by 20 minus X, this is the number of blue, and each blue costs 0.55. Okay, now this is less than or equal to 13. We're going to expand. So 0.7x plus 20 times of 0.55, which is 11, minus 0.55x is less than or equal to 13. So 0.7 minus 0.55, we get 0.15x is less than or equal to 2, because we're going to subtract 2 negative, we're going to subtract 11 on both sides. Then next we divide by 0.15, so 2 divided by 0.15, we get 13 and 1/3. X is less than or equal to 13 and 1/3, less than or equal to. They want to find the largest number of x, so you can draw a timeline if you want to. Okay, x is 13 and 1/3, greater than, less than, x is less than, so the other direction. Then the greatest value must be 13, because x refers to number of balloon. It has to be an integer. So greatest, x equals to 13. So now find the smallest value of x squared plus y squared. Take note, these are perfect squares. Okay, these are squares. So x squared, just a quick recap, x squared is x times x. If x is positive, then x squared also positive, because positive times positive gives you positive. Now what happens if x is negative? Then x squared is again positive, because negative times negative still gives you positive. What is the other option? The other option will be if x is 0, then x squared is 0 times 0, which is 0. Now out of these three options, which is the smallest? The smallest is when x is equal to 0, then x squared is equal to 0. If that is not an option, if 0 is not an option, then you have to consider both positive values of x as well as negative values of x, because regardless whether it's positive or negative x, you still get positive x squared in both cases. So let's start. I want the smallest value of x squared plus y squared, so I want the smallest possible x squared plus the smallest possible y squared. We check, is it possible to get 0 as x squared? Turns out, yes. There is a 0 over here. 0 exists. So I will definitely choose 0. So smallest x squared plus y squared is 0 squared plus, now let's move on to the y term. This gives us a range from -8 to -5. The smallest y value is -8. The largest y value is -5. But I want a square. So I want the smallest square. And keeping in mind that negative number, when you square, you get positive. So when you square -8, you get 64, positive 64. Versus when you square -5, you get positive 25. I want the smallest value. So I should be squaring -5 to give me just 25. Okay, question 16 was quite well done. Now let's move on to 17a. When you see this, don't be scared. You have to remember the three things I told you to memorize, which is a plus b squared. So a squared plus 2ab plus b squared. Now a minus b, when you square, you get a squared minus 2ab plus b squared. And finally a squared minus b squared, which is a plus b, a minus b. These three of them you have to know at your fingertips. Left to right, right to left. And what do you notice? This is a case of a squared or rather x squared minus y squared. Doesn't matter what is inside. You can rewrite it. So 3a plus 2b, you square it, minus a minus b, you square it. X squared minus y squared. We're going to be using this. So whatever is in the first term, 3a plus 2b, we are going to add to the next bracket, a minus b. Okay, so what we have done over here is this portion. Then we're going to multiply with your a minus b. So let's get started. Next will be our 3a plus 2b. We're going to subtract away a minus b. So this is the other portion, the other half of the expression. Now it gets simplified really quickly now. So 3a plus a, we get 4a. 2b minus b is plus b lah. Okay, next bracket, 3a plus 2b minus a, 3a minus a, we get 2a. 2b minus negative b, so 2b plus b plus 3b. And there you have it, it is factorized. You do not need to expand and simplify, then factorize. But doing so is still correct, just that it takes you more time. Okay, next one. The GST is set to increase from 7 to 9%. Find the new price of an adult Singapore City Pass 2 days after the increase in GST. So let's check out what is the original Singapore City Pass 2 days. Singapore City Pass 2 days for an adult. Okay, so this is the one. This price includes GST. Okay, you see the little arrow, the up arrow? Okay, so this 62.90 includes GST of 7%, which means that the original 100%, we don't know yet, but I do know that 107% refers to 62.9. The question is asking, what is the new price? So meaning 109%. What does it represent now? So with that understanding, we can write down our expression. 107% represents 62.90. And now 109%, which is the new price after increase of GST, will now represent same structure, divide, multiply. So 62.90 over 107 times 109. This is going to be the new price. 62.9, 107, 09. 64.0757. So 2dp, 64.08. Okay, now next one. At the end of the visit, he was left with $375 Sing dollars. Exchange rate as such. Find out if you made a profit or loss if you exchange this amount of money for Japanese yen again. Okay, so at the start of the holiday, it was 1 Sing dollar equivalent to 80.65 yen. So at the start of holiday, 1 Sing dollar 80.65. So our 375 Sing dollar will be equivalent to, do your calculation, so 80.65 over 1 times 375. 30,243.75 to do DP. And now at the end of the holiday, our 1 Sing dollar is equivalent to only 80.55. So our 375, do the same calculation again. Okay, so 80.55 over 1 times 375, not dollar, it is yen. 30,206.25. So based on this, there's a difference. If he were to change it, he gets less compared to at the start of the holiday. How much less? Difference is 30,243.75, 30,206.25. So the difference is 37.5. He will lose 37.50 if he changes again.